ahead with one slide, and then we'll move to the program for the afternoon.
Yeah, we just wanted to point out for people who are interested in our publications, and I'm just going to share my screen about where you can find them on our website. But I think if you navigate to our Biomonitoring California website, you go to our resources, and then under publications, we have a list of all our recent publications. And the first one was, I think we spoke about really briefly, is our latest protocol on arsenic speciation. So just wanted to highlight it for people who are interested in it. Thank you.
Okay, with that, now we're going to move into the next set of presentations. And in our next agenda item, we're going to be hearing from two speakers. Both of them are going to be talking about different aspects of biomonitoring for air pollution. Our first presenter is Jeff Wagner. Jeff is the chief of the Environmental Health Laboratory branch at the California Department of Public Health. Today, he will be presenting on the analysis of VOCs, PAHs, heavy metals, and particle data collected in the FRESSCA-Mujeres project.
All right, well, thank you very much. As mentioned, I'm going to be talking about some of the air components of the FRESSCA-Mujeres project. In the, unfortunately, small type, you can see that this is a great team effort between many different agencies, including CDPH, but also Tracking California from PHI, Central California EJ Network, OEHHA, IIT out in Chicago, advisor from LBNL, and also great collaborators from UCSF. Okay, so as an overview of the study, I just wanted to define again for people that FRESSCA stands for Filtration for Respiratory Exposure to Wildfire Smoke from Swamp Cooler Air. And swamp coolers, otherwise known as evaporative coolers. And this project was initiated by the community who had identified the risks from summer wildfire events with their residents who use evaporative coolers, which is a very affordable way to cool down homes in hot environments, hot, dry environments in the summer. Unfortunately, they bring in a ton of outside of air, which you don't really want to do when there's a wildfire smoke event. So from that, we put together a team that was designed to both provide a solution as well as evaluate those solutions, how effective they were, and the community participants' exposures. And all these participants, by design, had evaporative coolers in their homes. So we provided first of all, designed and then provided DIY filters for those evaporative coolers, as well as indoor air cleaners. And that was kind of the approach we took to provide cleaner indoor air, cleaner, cooler indoor air. So those filters from the evaporative coolers were analyzed both for their particulate loading as well as metals. And now with our collaborators at Berkeley, looking potentially at COXY. We also incorporated low-cost PM sensors and a variety of air measurements, both indoor and outdoors at these residences. And then ultimately, we've begun some of the results return, which I'll mention later in the presentation at community meetings. A huge part of the study, which I know all of you will be most interested in, is in the biomonitoring. So urine samples were taken, analyzed for chemical biomarkers. There's also saliva samples, and some of our partners are working on biomarkers of stress. And I just wanted to mention on the left, you see some of our great team out there putting some of these DIY filters on the evaporative coolers. And then below that, a typical indoor air sampling setup. You see also on the left, lower left, the indoor air cleaner, like a typical indoor air cleaner that was provided, along with the sampling pumps, And then on the lower right, or the most lower right picture is a purple air sensor with a tiny little passive particle sampler above it. So in order to do this somewhat ambitious project, we assembled 3 different funding sources, which you can see in this diagram, the sort of overlapping collaborators that came from that. And then that in turn was able to fund and enable this huge variety of measurements that I just mentioned. And I just kind of want to visually show what proposals all those measurements corresponded to. So the study design involved 2.5 months primarily of indoor-outdoor PM data for 50 homes that all had swamp coolers in Kern, Fresno, and Kings counties, primarily two study areas, one in Kern and then one around the Coalinga area in Fresno, Kings. And 50% of those homes were provided EC filters. 50% had the ECs but no filters, and then all homes were provided air cleaners. And the diagram on the bottom just kind of highlights the fact that the EC filters are just by design going to work only on outdoor exposures like wildfire events or other high outdoor PM events, whereas the indoor air cleaners can work on pollutants that are generated both indoors and outdoors. So in addition to this kind of 2.5 month assessment, we did short-term airborne chemical samples timed with urine samples. And the ideal would be to target those during a major wildfire event in the study area. However, during the study, there were no major wildfire events. So our default was to do it during the last week of the study, and that's what ended up happening. A little bit closer look at the air methods. As I may have mentioned, for the continuous low-cost PM 2.5 sensors, these are purple airs that we ended up using. And we did a co-location study ahead of time, and those worked pretty well for this study. At the same time, we used passive PM samplers, which is a very different but complementary technique, which just takes one integrated sample over the entire period. They're analyzed with scanning electron microscopy. You get 1,000 individual data sets per sample corresponding to individual particles, and that can be used to give you PM size distributions, PM 2.5, PM 10, as well as major particle types kind of attributed to their likely sources. For the short-term samples that were done in the final week and timed with the urine, we took air samples with pumps of metals, VOCs, and PAHs. And those are 3 separate sampling setups that could be then sent to the individual analyses, which in this case were ICP-MS for the metals, and then 2 different setups for GC-MS for the VOCs and PAHs, the gas phase compounds. So quick look at some of the results. For the passive PM, this is a look at indoor-outdoor ratio, which was obtained from the co-located indoor-outdoor samples for individual homes. And the main point I wanted to convey with this slide was just that for PM 2.5, in all these homes, the indoor-outdoor ratio was less than 1, slightly, to which we attribute the indoor air cleaners. We didn't see a huge difference between the homes that had the EC filters, just because we think that there were no wildfire events of any significance during this time. This slide adds the PM10, and you see that in general, the indoor-outdoor ratios were even lower, averaging about 0.4 across all homes. And that makes a lot of sense to us based on the typical collection efficiency of the filters, both on the ECs and on the indoor air cleaners. They tend to work better for bigger particles in the range of 2.5 to 10 microns. There's also some of the effect of the building envelopes themselves tend to filter out the biggest particles, although these were not, these were often trailer homes. So we're not sure about that building envelope filtration, but this in turn was interesting to us because as I'll show in the next slide here, the crustal component of this PM was just by far the biggest component that we measured with the passive samplers. And those tend to be coarse particles. And we had participants report back that they felt like the interiors of the homes even were qualitatively cleaner using these interventions, just because there's so much dust in this area. And as many of you know, the coarse component of PM10, though not as strong an association with health effects, does have an association with various respiratory health effects, including asthma. You can also see in this picture the examples from the electron microscopy of some of the other types we found. So there's carbon-rich particles, which are comprised both of biogenic spores, as well as vehicle emissions and smoke. There's a sector we've associated with agricultural products that are rich in phosphorus, chlorine, and potassium, such as fertilizers. Salts, which are a very minor component. And another minor component that is nevertheless of interest is metals. This is a picture of a copper-rich particle. And when I looked at the copper results across all samples, it was interesting. We found them in all indoor samples, but primarily in Kern County with higher levels. And that was the county where we found them outside as well. So because we were looking at individual particles, we could see that the copper was associated with chlorine and sulfur, which suggests a fungal or pathogen treatment for crops. Although it is possible that it's also a consumer product that is used for indoor plants, the fact that we saw them outdoors to such an extent, as you can see here, suggests that they were an outdoor application, and perhaps in Fresno and Kings counties where we didn't see them outdoors, that suggests that they were not applied outdoors during the study period, but had been perhaps applied at a previous date and had accumulated indoors over time. This is a look using electron microscopy again at the swamp cooler filters themselves. And you can see just more qualitative evidence of their effectiveness at collecting PM. In this case, at this magnifications, you're seeing mostly coarse PM, those kind of crustal dust particles. Now I'll look at some of the data from the low-cost PM 2.5 sensors. Those had the advantage of being able to take thousands of data points over time. And a really good example of what can be done with that is looking at, in conjunction with the plug load loggers, which show whether the indoor air cleaners or the swamp coolers were turned on at any given moment or turned off by monitoring their power draw. We could do a comparison of indoor PM 2.5 when both the air cleaners and swamp coolers were both on compared to when they were both off. And this is a nice illustration of the effect of our indoor air interventions in a typical home. You can also, with the low-cost sensors, see temporary transient spikes in PM, many of which we believe to be due to indoor events rather than outdoor events. But an exception would be in the section that's blown up from September of last year. You can see this kind of bump in the outdoor concentration, and that did correspond to a minor wildfire smoke episode, I believe from the California-Oregon border. Now moving on to some of the short-term sampling. As far as the metals go, we measured across the typical range for an ICP-MS on the order of a dozen metals, but I'm showing in this slide the metals that were above detection limit in these homes. So iron was by far the most prevalent, which makes sense as a major component of soil and dust. It was much lower indoors, which is encouraging for all these homes with indoor interventions. We also detected manganese, copper, zinc, and selenium. And of all these, I only showed the OEHHA recommended exposure limit for manganese as being higher than what we found, but of the same order of magnitude. It was much higher for all the other metals. Rather, the REL was much higher, and the exposures were much lower than the REL. So moving on to VOCs, the dominant compounds in these analyses ended up being the BTEX compounds, benzene, toluene, ethylbenzene, and xylenes. The relationship between indoor and outdoor was not consistent between compounds, although we're still finishing the data analysis for those, but that would make some sense since neither of our indoor interventions were targeted specifically at gas phase compounds. Most of them did have a carbon layer on the filters designed for odor control. So we were hopeful, but we're still digging into that. There's some evidence that maybe those work over the short term, but not so much over the long term. I should mention also that in homes where we detected relatively more rare VOCs, which were attributable to certain sources, we conveyed those in the results returned, such as compounds which are found in nail polish, for example. The polycyclic aromatic hydrocarbons measured indoors were dominated by the naphthalene compounds, but you can see perhaps a list going up to pyrene that we measured. As far as indoor-outdoor ratios, again, much the same for the VOCs. They tended to hover around 1, with some exceptions, notably pyrene, and we're looking into basically because the pyrene had such a low indoor-outdoor ratio that it looks like it has an outdoor source. So I mentioned the community meetings, and you heard about it earlier as well, that we had in August that were targeted just on the air results, not the biomonitoring. And those were super valuable, not only to help clarify in person what the packets represented as the packets were returned to participants, but also to communicate exposure reduction strategies for any metals or chemicals that were detected in a given participant's home. And we also received a lot of valuable feedback about community concerns about things in their air, which will be very useful for informing our work in the future, I think, including things like local dust generation events due to agriculture and concerns about how to reduce VOC exposures from cleaning products in the home. So in conclusion, our FRESSCA and FRESSCA-Mujeres projects evaluated indoor air interventions to improve both air quality and thermal stress. And I feel that we were able to use an ideal combination of passive samplers, low-cost sensors, and speciated chemistry samples to give a real balanced amount of information. In general, we found that the PM was lower indoors with our combined interventions of air cleaners and EC filters, particularly perhaps due to dust reductions. The highest metal was iron, again, lower indoors with a few other metals detected. For the gas phase compounds, VTEX and naphthalene were the most abundant species. And then just again, these community discussions were really valuable and will inform our future work. And thank you for your time.
Thank you very much. We now have roughly 5 minutes for questions, first from the panel and then from the audience. So are there panel members? I can't see online. Our panel members who are on Zoom. Jenny, yes, go ahead.
Hi, I'm Jenny Quintana. I just had a clarifying question about, you had a slide about the reduction in indoor PM, the situation where it was both were operational and then both were not operational. So yes, air filters on, and yes, swamp cooler filter was in place, and then no swamp cooler filter and air purifier off. But did you have data on where there was no filter on the swamp cooler to make that comparison? So basically you felt like the filtration was not useful from the external filtration?
So
You had one
yeah,
condition on that slide that I was confused at, but you didn't seem to have all the conditions for that indoor PM.
right. So yes, that is a good point. And we're actually still looking at that condition of when the swamp cooler was used a lot, but without a filter, and whether you would expect that to have like a negative impact on indoor concentrations. So yes, I agree, and that's something we're looking into right now. I can't remember if there's another part of your question.
No, that was
Yeah,
main
thank you for that.
Yeah, and thank you for this important work to, especially using DIY kind of interventions, which might be scalable. So did you collect indoor dust from the home as well, or no? Besides the passive sampler, did you take any bulk samples of like?
No, we did not. We did not. And I don't think I mentioned that there was also some associated survey information collected, though, with this study that I wasn't directly involved in, but I know part of that was targeted on willingness to pay, because you mentioned the DIY aspect of this. And I should have mentioned also that the goal of this solution was to be both effective, but also somewhat affordable, and being able to be implemented by the communities directly with tools they could easily obtain. So I believe we arrived at something like $100 to $200 for an installation, which may be above. It's affordable for some, but not for others. So that's another caveat I should point out.
Thank you. Carl had a...
Yes, thank you. Interesting study. What I would be interested in is the concentrations, let's say, of PM 2.5, both outside and inside. Where do those stand vis-a-vis, say, Cal EPA health standards or US EPA health standards? Can you address that? I mean, you have interesting inside-outside comparisons, but what are the health consequences one way or the other?
Yeah, I'm wondering if I can succeed in resharing this slide. Yeah, thank you for that question. The closest that I showed was this plot, where there is the 24 hours current 24-hour standard and the current annual standard on this plot. And you can see that the 24-hour, the scale on this graph is between September 20th and September 27th. It's too small to read. And it appears this was the highest outdoor episode that we saw. And it was not exceeding any 24-hour standards during this time. And we only ran for 2.5 months, but I just put the annual standard as a comparison. That's a question also that we're going to have to dig into deeper as we're writing our manuscripts at this point, is if this holds true for all locations, because the 2 study areas did span quite a wide range with a lot of heterogeneous exposures in that part of the valley. So I appreciate your question, and we'll be comparing to the both the state and federal standards.
Thank you.
I have 2 questions. The first is for the PAHs in urine and air. I was wondering if you've done comparisons between them and if the temporality is close.
Yeah, that's definitely a challenge here. I believe, and somebody in the room can correct me if I'm wrong, but I believe we took definitely first void in the morning urine, and then overnight air sampling, and then I believe there was one before going to bed that night. So we're hopeful. The pH results should be ready pretty soon from the urine. So yeah, thank you.
My second question was, I was also curious. I think this is a really interesting and great study. I was wondering if you had any instructions for when to turn the indoor air filters on, and if it sounded like you had a way of knowing when they were on by the electricity pole, and if there was if you needed to supplement for electricity bills, or if that's a barrier for future studies.
Yeah, that's a really good question. Since we have power draw data, and that presumably maybe we have electrical rates, that would be a good thing to include for the economic feasibility for residents for sure. And I've seen the instructions that were provided to residents for putting these things on and buying the materials, but I don't recall if they were more detailed than like if there's a wildfire smoke event. Then yeah, it's been an interesting dialogue actually, because that was definitely the original intent, is to use them only when there's a wildfire smoke event. But I think it was pretty popular with participants like other times too, especially if it's a dusty place. Yeah.
And then I think Jenny has a question. Yeah. Your hand is up.
Hi, I just wondered if the participants had similar home volumes and room volumes where the air filter was operated, because one thing we're struggling with a filter intervention is, do we give more air purifiers to people with larger homes, or how do we kind of account for the volume that the air filtration unit will clean? And if you have any thoughts on that, I would love to hear them. Thank you.
Yeah, I definitely agree. We were delving into the square footage data this week to see if it would impact the indoor air cleaner effectiveness, because as you say, that's a key component. I will say that the vast majority of these homes were manufactured homes, but I don't think 100% of them were. So yeah, we'll have a little bit of data to look at that spectrum.
I also wondered about window opening behavior. So if you had any measurements such as CO2 or anything that would help shed light on that, or if you had any thoughts about recording that kind of behavior in terms of if the windows were open or not, or.
Yeah, no, I think that's a very key component as well. And I think there was one survey question, but that can't really capture temporal variability. Some data we were just looking at, there was a moment in this home we were looking at where the indoor PM 2.5 concentrations rose suddenly up to equal the outdoor air concentrations for like a half hour. And that spoke to me of some kind of window or door opening event. I wonder if that could be done with just the PM data, with the co-located indoor-outdoor data.
Interesting.
I'd like to take a moment here to see if there are audience questions or questions online, and then we'll come back. We have more time for in-depth discussion. Nothing online? Okay. Any audience questions at this point? And then we'll open it up to the audience again after we kind of go now into our more official, deeper dive discussion.
Thank you.
No, you're.
No, he's still.
You're the subject of. This
Almost
time
got
we're
away.
doing each talk with a detailed discussion after the talk, whereas before we waited till both talks were done. More questions? Yes.
I'm not sure this is somewhat of a deeper dive. It's related to the PAHs. So, I was interested in the fact that the naphthalene, compounds were high in the measured indoor air, but then when you looked at the indoor versus outdoor, they were not the highest. And I'm wondering if you had some thoughts about, what the sources of the compounds that were higher, the PAH compounds that were higher in the indoor, versus outdoor air. I think it was phenanthrene, acetylene, I think. Can't really tell the colors exactly, but yeah, those two for sure. Oh, and no, not fluoranthene, fluorine 6.
Yeah, no, that's a very good point. And I only noticed it as jumping out for the pyrene as being a real outlier as far as indoor outdoor, but I do expect, especially from cooking, to have some pH sources indoors for sure. Yeah, no, so the short answer is we haven't gotten there yet, but I would like to do some pH specific source identification. There's also quite a bit of petroleum industry down there as well, so I think that's relevant as well.
I had a question about purple. Oh, you think, yeah, about the purple air, and you had those indoors, right?
Yes.
Did you have any outdoors?
Yes.
So you had
Yeah.
indoor and outdoor, right?
Yeah, although it wasn't the same kind of coverage. It was basically like one outdoor per city, and we had to measure how many kilometers it was from the indoor. Yeah, they were considerably more difficult to deploy, I know, because of power sources and shelter and that sort of thing. Yeah.
And did you calibrate the purple air against? I mean, I know people who calibrated them and they work fairly well, but it's useful to know. Because
Yes.
they have some variability, but on average, they do pretty well.
Yeah, that was definitely an interest of ours. And I think we're going to be submitting a manuscript just on that part because it was so complex. We initially thought that we would need to co-locate with the federal reference monitor, but then when we thought about the point of the study is not really, the point of the study is indoor outdoor ratios. So it's more important to make sure that they all agree with each other. The precision, in other words, was more important to us than the accuracy. But even that was a challenge because we had something like 80 purple airs. And we have a garage at CDPH where that was not a problem, but getting Wi-Fi access for that many units at the same time was unexpectedly challenging. To have 80 Wi-Fi connections in the same room. So we're planning a study right now in Oakland that's going to have maybe 4 or 5 times that, and we're just really struggling with how are we going to run this many Wi-Fi connected devices in the same place. What we did for this current study is we did 3 batches with some overlap between individual units, and then regressed the mean of all 80 sensors against each individual one. And we did that pre and post study. I think that they performed so well as far as consistency over, granted, only 2.5 months. But the main utility of that was identifying ones which were just never going to perform. They were just bad units from the moment they came out of the box. And there was a few of those. So it was really useful to not learn that after the study was over. Yeah.
I mean, sorry, now that we're on purple air, people are cooking greasy foods and frying. Did you see that show up?
Yeah, I think all those spikes, a lot of those spikes in that one plot were definitely cooking. And because this is a somewhat outdoor focused study, our colleagues at IIT are working on automated algorithms to identify very short-term spikes and do a separate analysis without them, with the assumption that that's a screen for indoor generated exposures.
Other questions? Discussion point? Comment on the panel? Okay.
I have a question about the VOCs table for that chart that you show there. The first question is, are there significant differences there? Were there statistically significant differences? Do you have enough power to look at differences? I see that probably benzene had the biggest difference between the outdoor air versus the indoor airs. So let's see.
See if I can get that slide up. Yeah, so I believe this is about. Oh,
Yeah. I think maybe 17, perhaps.
thank you.
There.
Apologize for the small view. Yeah, so you're speaking of the relatively low indoor-outdoor ratio for benzene.
Oh, for benzene, yeah, there's like a big difference between outdoor air versus the indoor air there. Does that
Yeah.
reach a statistically significant difference between them?
Judging by the error bars, I would believe that that is not very significant. But we have yet to compute those stats. So I think what we will be planning to do would be to correlate those kinds of statistics with molecular weight, as well as typical indoor and outdoor sources. I mentioned a little bit before about the carbon filters that are on. Actually, we found filters for both the EC units and the indoor air cleaners that had like an odor control layer, which has some potential to capture some of these compounds. And our collaborators at IIT are also doing a lab study on, unfortunately, I can't recall if benzene was one of the most highest capture efficiencies, which would be one explanation for that relatively low indoor-outdoor ratio. But the problem with that type of activated carbon medium in general is that things that adsorb to the media tend to desorb from the media eventually. They don't stay there forever. So, but yeah, I appreciate your question, and yeah, we will be looking at it. Thank you.
Yeah, maybe one of those. So if you remind me, there were a total of 29 homes that received the intervention, right? And they were divided, how many in each one of the groups again?
So for the EC filters, it was roughly half and half for the 50 homes.
Okay.
Yeah.
I'm just looking into what you're presenting here, and maybe I'm looking a little too hard at this, but it's kind of interesting. But so if you look at all the trends there in all of these different VOCs, the concentrations are highest outdoors and lowest with the indoor and the EC filter, with one exception, which is styrene. And you see styrene is actually highest with the swamp cooler filter plus the indoor air versus the indoor with just the indoor air filtration versus outdoors. It's very small, but it's kind of striking that it goes in the opposite direction of all the other ones.
Yeah.
And then if you think about it, and I wonder what type of filters they have, but a lot of the filters do have some styrene in them, different plastic components into that I think tend to be relatively stable actually, unless there's heat involved. And so it makes you wonder a little bit, if it's outdoors, and if it's hot, then we're releasing some. On the contrary, though, for that is that maybe you do see a little gradient there, but perhaps it doesn't, the amount of release is so small, you're just tracking that maybe there was the use of something that included styrene, like in the filter or something like that, and maybe not necessarily a filter.
Yeah, it is a pretty small difference statistically, but I appreciate your point that some of the materials used in those filters, we don't want those to become pollution sources. We were particularly concerned about filters that may get wet in defective evaporative coolers and then become a mold source. So that was one of the reasons we looked under the microscope at the filters to see if there was any evidence of like hyphae and like extreme mold growth. And we didn't see that, luckily, although we did see a few units that were pretty wet. They were mostly notable because there was a lot of like lime and calcium deposits on the filters from all that water. So,
well, thank you.
All right, and unless there are burning issues, so we have one audience comment.
Jenny online.
Oh, I can't see. So Jenny, you have a question?
Just a very quick one, which is just when you left the participants, when they exited the study, did you leave them the units and how many extra filters did you leave with them? Just in terms of participating in the study?
So for the swamp cooler filters, I believe that part of that community meeting was an exchange where they would get a new filter, or I'm sorry, can somebody correct me? I think that was for the indoor air cleaners, not the swamp cooler filters. Yeah. I know that every participant received new filters on the way out. I think Rebecca's coming up. And then we did have to take back the percolators, but we are working with the community to deploy percolators outdoors, some of those units permanently outdoors.
Yes, so all the participants that attended the community meetings received a replacement filter for the air purifier as an incentive. And then we've left some replacement filters for swamp coolers with our community partner if they were to request that. But we've also given them information on where to purchase.
Thank you.
And we did hear anecdotally from our partners that there was a smoke event in the Coalinga area, unfortunately after our study was over, but they observed some of the residents going out and deploying these swamp cooler filters. So that was encouraging.
Okay, well, thank you. Now we're going to move on to this second presentation in this session. Our next speaker is Kimberly Valle. Kimberly is a doctoral candidate in public health at the University of California, Merced. Today, she will be presenting on urinary biomarkers of response in relation to air pollutants in adults and children in the San Joaquin Valley.
Hello, everybody. Today I'll be presenting on the preliminary results for urinary biomarkers of response in adults and children from the San Joaquin Valley. One second. Great. I would like to mention that the content is solely the responsibility of the authors and does not represent the official views of the collaborators involved. The authors declared no conflict of interest, and this research was supported by grants from the California Air Resource Board and the California Office of Environmental Health Hazard Assessment. This work was made possible through the collaborator and support of these organizations. And I would like to begin by providing some background on air pollution. I'm pretty sure you all are very familiar with the topic, but just some general information that exposure to air pollutants such as particulate matter, nitrogen dioxide, and ozone have been associated with adverse health effects. The San Joaquin Valley is an area burdened by high air pollution, and indoor air quality is especially important because children and adults spend most of their time indoors. Several factors contribute to poor air quality, and that includes smoking, cooking, the use of candles or incense, poor ventilation, and of course, the infiltration of traffic-related or other outdoor air pollutants. So today we have heard about Biosphere, which is the biomonitoring component of SPHERE. And as a friendly reminder, SPHERE is a San Joaquin Valley Pollution and Health Environmental Research Study. And this is the study where dedicated to the environmental measurements, and adults were eligible participants included adults 18 years or older with a child between the ages 3 to 13. This resulted in 64 parent-child pairs being part of the study. There were residents of Stockton and Fresno. Study participants included 12 families in Stockton and 52 families in Fresno. They were Spanish or English speakers, and the sampling took place between February through November of last year. For Biosphere, which of course is a biomonitoring component of the study, 64 parent-child urine samples were collected. For a subset of 8 families, daily urine samples were collected over 4 consecutive days. Now, the urinary sample measurements included biomarkers of exposure, VOCs, PAHs, tobacco, and smoke, which I will not be talking about today, but I will be talking about the biomarkers of response indicating oxidative stress, inflammation, and airway injury. The biomarkers of oxidative stress included 8-isoprostane, and 8-isoprostane indicates like lipid peroxidation caused by reactive oxygen species. High levels of 8-isoprostane reflect oxidative stress, and the other biomarker of oxidative stress is OEHHA, which reflects DNA damage. Increased levels of OEHHA have been associated with oxidative damage and generic material. Prostaglandin E2 is a biomarker of inflammation and may indicate the body's response to environmental stressors, and high levels of air pollution exposure have been associated with increased inflammatory responses. Claricell protein 16, also known as CC16, is a biomarker of airway injury to the respiratory tract lining. Now, several studies show that long-term exposure to air pollutants damage CC16 producing club cells, leading to decreased levels of CC16, which might result in decreased lung function. However, other studies have demonstrated that increased concentrations of CC16 can also indicate airway injury due to short-term air pollution exposure. So there's this, according to the literature, there's this information that long-term exposure may lead to lower levels of CC16, but short-term exposure leads to increased levels. So for what I'm presenting today are the study objectives, which were to examine the distribution of 4 urinary biomarkers of response in adults and children from the San Joaquin Valley, to evaluate the association of the biomarkers with measurements of air pollutants in participants' homes, and to characterize the temporal variability in the biomarker measurements over several days. In terms of the study design for the urine samples, this included 64 parent-child pairs. The urine samples were morning samples, and most of them were first morning void. For a subset of 8 families, samples were collected over 4 consecutive days, and urine sample measurements included 8-isoprostane, AOHGG, PGE2, and CC16. All biomarker measurements were adjusted for specific gravity and log2 transformed. Now, metabolite concentrations were specific gravity adjusted to account for urine dilution, and we use specific gravity instead of creatinine to adjust concentrations because age has a significant impact on urinary creatinine levels. So the urine samples were analyzed using ELISA kits, and they were analyzed by the Holland lab at UC Berkeley, and each biomarker was evaluated using the respective ELISA kit, as we see on screen. Now, for the indoor air monitoring, average computed 12 hours prior to the urine sample. And here what you see on screen is a picture of the indoor cart that was deployed. We use the Sunset ramp from Sunset Technologies to collect real-time indoor air quality data, and we collected information on, data on nitrogen dioxide, ozone, and particulate matter. For the analysis, the air pollutants were log2 transformed. Now, this table presents the demographic characteristics of the parents or the guardians. And now I want to point out that the number is 63 because there were a participant that provided very low volume, and therefore, when looking into the urine samples, we were able to analyze 63 of them. So here we have the demographic characteristics for the participants, which included nearly equal distribution of Spanish and English speakers. Most participants were female. Most participants were Hispanic or Latino. Most of the participants were the parent of the child with the mean average age of 42 years old. Most participants have not graduated from high school, and the family annual income was up to $30,000. Now, this table presents the demographic characteristics of the children, and similar as the parent, we had 2 children who provided very little volume of urine. Therefore, we were not able to complete the analysis. So we almost had an equal distribution of male and female children. The average age of the child was roughly 9 years old, and roughly 60% of the children were in the BMI category of being overweight or obese. This figure presents the distribution of oxidative stress biomarkers in adults and children. To the left, we see the levels of 8-isoprostane, and to the right, we see the levels of OHDG. Now, I do want to mention that they each have their respective values on the y-axis, and both biomarkers had an 100% detection rate in adults and children. We conducted a t-test to evaluate the differences between the adults and the children, and we observed no significant difference in biomarkers of oxidative stress among adults and the children. Now, this figure presents a distribution of PGE2 and CC16 in adults and children. To the left, we have the levels of PGE2, and to the right, we have levels of CC16. Again, they have different values on the y-axis. And for the adults, both biomarkers had a 98% detection rate. However, for the children, they had a 100% detection rate. We conducted a t-test to evaluate the difference for the adults and the children, and PGE2 was significantly different in adults and children, with children having higher levels of PGE2, while CC16 did not statistically differ from the adults or the children. Now, previous scientific findings have explored the relationship between the 4 biomarkers and age and BMI. Although the results are not displayed here, we did not observe a significant association between the biomarkers and age or BMI. Now, we did investigate the sex difference among male and female children, and that is what is displayed on screen. And this figure presents the significant mean difference in biomarkers of oxidative stress and airway injury in children. So female children had higher levels of OHDG, and female children had statistically significantly lower levels of CC16. We evaluated the short-term temporal variability of the four biomarkers of response, and this was the analysis conducted with the subset of families which provided samples over 4 consecutive days. And we observed higher within subject variability compared to between subject variability among adults and children for the biomarkers of oxidative stress and inflammation. However, we observe higher between subject variability compared to within subject variability among adults and children for CC16. These results suggest that while 8-isoprostane AOHDG PGE2 levels fluctuate considerably within individuals over time, CC16 levels are more stable with greater variability in participants. Now, in summary, so far, there was no significant difference among parent-child pairs for biomarkers of oxidative stress and airway injury. PGE2 was higher in children compared with adults. Female children had higher levels of AOHDG compared to male children. Female children had lower levels of CC16 compared with male children, and there was higher within subject variability compared with between subject variability among adults and children for biomarkers of oxidative stress and inflammation. Now, there was higher between subject variability compared within subject variability among adults and children for CC16. We investigated the relationship between the biomarkers of response and indoor air quality. And here we have on screen a table that shows the indoor air quality measurements for the participants 12 hours prior to the urine collection. And I do want to point out that these are 12-hour averages, which make it difficult to compare the national air quality standards, especially because we're also focusing on indoor. But I do want to get your attention to the levels of PM 2.5, which are very high, and the 24-hour average national air quality standard is 35 micrograms per cubic meter, but we do observe that in the Central Valley, we have families with 12-hour averages that reach above 90 micrograms per cubic meter. Now, we conducted linear regression models, and we observed that a twofold increase in nitrogen dioxide exposure was significantly associated with a 2.4 increase in adult urinary PGE2 concentrations. And we also observed that a twofold increase in ozone was significantly associated with a 2.6 increase in adult urinary CC16 concentrations. So among the children, we observed no significant associations between the indoor air pollutant and the biomarkers of response. So in summary, few studies have examined these biomarkers in communities disproportionately impacted by air pollution. None have examined short-term temporal variability. Among adults, we found positive associations between indoor nitrogen dioxide levels and PGE2 and indoor ozone levels and CC16. No significant association between air pollutants and the child biomarkers were observed. And except for CC16, the higher within subject variability suggests that single measurements may not characterize long-term oxidative stress or inflammation status. And the high short-term variability could point to impacts of short-term exposures, although we did not observe the association between the measured air pollutants and response biomarkers in children. Additional studies are needed to better understand the nuances and utility of these biomarkers and indicators of air pollutant exposure and morbidity. Now, there are additional extensive laboratory measurements. Here we see a table of the additional laboratory measurements, who are they being analyzed, and the status of each laboratory analysis. So the additional laboratory analysis include VOCs, urinary VOC metabolites, urinary PAHs metabolites, coating, PAHs in air, and VOCs in airs. The next steps are to evaluate the biomarker measurements in relationship to urinary biomarkers of VOCs, PAHs, tobacco, and smoke. I'm looking into outdoor 24-hour monitoring for nitrogen dioxide, ozone, and particulate matter, PAHs in the air, indoor and outdoor, VOCs in the air, also looking into nearby traffic metrics, apologies, and looking into levels of criteria air pollutants from community science, which are purple air monitors, and regulatory monitors over short-term and long-term, for example, looking at days, weeks, a month prior to the urine collection. And we do have questionnaire information on asthma diagnosis, medication. So of course, looking into these biomarkers and the questionnaire data. We would like to give thank you to our community partners for their support and contributions to this project. And also we would like to thank and acknowledge the support of the contributors, which the list is much longer, but yeah, we want to say thank you.
Thank you very much.
Yeah.
Once again, we're going to begin with a short period of questions, more of a clarifying nature, starting with the panel and then going to the audience. And then after that, we'll have roughly 15 minutes for more in-depth discussions and questions. So we can begin with the panel. Any questions to begin? Oh, Jenny, go ahead. Once again, my viewer blog.
Hi, Jenny Quintana. I was just wondering if in your future plans that you thought you might try to figure out how many subjects would be needed given the variability, like just to inform future studies. If they could only take one sample, would they need 10 times as many participants, that kind of thing? And I'm sure it would vary by biomarker, but it might be very useful to help inform future studies.
Yeah, I think that's yeah, of course. I'm going to invite Asa as one of the PIs of the project to answer that question.
Sure. Okay. Thank you. And Kimberly, I want to congratulate you. Great job. Yeah, I think that's a really good point. And kind of like with the EdDepth study where we had repeat samples for the 1-nitropyrene, this is actually the first study here that I think we could find that's ever been done, actually looking at consecutive daily sample for these biomarkers, and both to better understand the short-term variability, but absolutely we can use that to see what kind of power do we need to do a larger study. And so as far as we know, this will be a contribution to the literature in that arena.
Thank you. And I forgot to congratulate the speaker on a really well presented talk and very clear. Thank you.
Thank you.
Other questions from the panel?
Question.
Yes, Jose.
I have a question that I'm still trying to formulate. So CC16. So I see the use, right, of trying to have certain biomarkers to track health that would be easily collected via urine in this case. So you select a few different ones. CC16 seems to be kind of a challenging one, right? As you very well mentioned, chronic exposures, I think you said it was lower concentrations, and then acute exposures higher, or vice versa. I can't remember, which is very puzzling in itself, right? With these associations. So the way that I interpreted that with the associations that you found there, would those be mainly tracking the chronic exposures? So the associations you were finding with the positive associations in adults of CC16, would that be more reflective on a chronic effect of the exposure?
So we saw a positive association between like ozone levels and CC16. So in this case, I think the biggest thing is how we are defining exposure. So in this case, since we were looking at 12 hours prior to the urine sample collection, that would be a short-term exposure. So we would expect an increase. However, I do think that that is one of the most challenging aspects of CC16, which goes into the definition of what is a time frame of exposure. I know for individuals with chronic conditions, CC16 levels tend to be lower, given that their respiratory health is not functioning as, for example, healthy individuals. So I think this is when you get into like the nitty-gritty of the study design and how exactly are we defining or measuring exposure with these biomarkers.
Yeah, which is a challenge in general with environmental health. You have a biomarker, and if it's a very short half-life biomarker, then you're really tracking a short exposure. But then you can say, well, maybe the day-to-day exposures are correlated with each other. Maybe that short-term exposure, has a correlation with the long-term exposure, but challenging with this particular part. And I thought it was interesting also you're finding there with just the differences comparing children versus adults with inflammation markers. What are your thoughts?
Yeah, definitely. So this was a question that came up during my practice run, that it's like, why did children have higher levels of inflammation? And I did do a little bit of more back end, and then a few children did report that they had flu-like symptoms. So they were experiencing flu symptoms. So that can be an indicator of why we see these high levels of inflammation in the children. Then other children reported that one of them sprained their arm, and another, like they had some type of they were feeling sick. So I think that provides information on why we saw increased levels of inflammation in children. Now, going back to your question about the differences, I think that this is just a tiny little, these are just results compared to like the big picture. I'm definitely interested in looking at these biomarkers and looking at the outdoor, the traffic related air pollutant information. A lot of the literature has looked at 1 week, 1 month, 6 months, and as part of the questionnaire we do have information on how long the participants have lived in their home. So I think that information can provide a better picture of the exposures the children and the adults are experiencing.
Mm-hmm. Yeah, well, which kind of brings up an important point, right? So you would either want to account for that or perhaps restrict the participation, the inclusion of the data of participants that have some sort of a chronic health condition or an acute inflammatory condition for these differences. Although interestingly though, in one of our prospective cohorts of children, we were surprised by this as well. So we looked at a lot of different biomarkers in serum, including CRP, TNF-alpha, ICAM, BCAM, SAA, and a few others. And for all of them, the concentrations were much higher in younger adolescents than they were in older adolescents, very strong differences. And so we were scratching our heads. We would expect the younger people to have less inflammation than the other ones. Maybe that really applies to older adults versus younger adults. But something that we're thinking is happening is that there's a normal amount of inflammation happening in development. As children are growing, there's a lot of inflammation because their tissues are stretching. And so that could be something we're thinking about here in the write-up of things. What exactly, in this case, it's prostaglandin E2, what exactly it's tracking, and can you link that to what other studies have been observed, for instance?
Of course, thank you so much for that information.
Before we go into more substantive discussions on the panel, I would like to just take a minute to open up to any early audience and online questions that we may have. Yes, we have one here in the audience.
I just had some
please
thoughts.
identify.
The conversation is so stimulating. Excellent work. I'm just so proud of you doing work that is so powerful and so vanguard. But perhaps we're looking, at the differences between inflammation and biomarkers in children versus adults. Maybe we're looking at behavioral, anthropometric differences. Children are outdoors, they're playing more actively. They are smaller creatures. They're closer to the ground, closer to the, earth. They're breathing more rapidly and, taking in potential sources of inflammation. The other point I'd like to make very quickly is that obesity is a pro-inflammatory state. And I know that we're looking specifically at biomarkers for airway injury. But obesity itself is a pro-inflammatory state, and perhaps there's something there. And then, of course, there's the immaturity of the immune system. So I just wanted to make those points. Another quick point, excellent work, PM 2.5, the medical literature is very profound in identifying that ultrafine particulates, less than a tenth of a micron, those are the ones that cause the most damage. They stay in the longer. They're associated with hypertension, ischemic heart disease, strokes. So ultimately, that's the direction we're moving in. And then the final point, Medicare does authorize a physician request for durable medical equipment for air purifiers and filters for individuals who meet medical necessity.
Thank you. Could you identify just for the
Dr.
transcript?
Himson Chai, Hunters Point Biomonitoring Program.
Thank you.
Thank you.
Other audience or online questions? Well, we can now move into more. We were starting a more substantive discussion anyway. I want to expand a little bit on this issue of, especially the effect biomarkers. How frequently are those associated with other factors that are not air pollution? Stressors, other stressors in their environment, diet, but also even factors people have shown, linguistic isolation, education level. There's a lot of things, employment status that can trigger some of these markers in the same way that you would see from air pollution. And is there some ability at least to record what those factors are from questionnaires and how they might play in?
Thank you for your question. So we do have information as part of the survey questionnaire on diet. Some of the literature does indicate that diet can be a big factor, like you mentioned, influencing these biomarkers. So of course, as we think about the future projects or looking into the analysis I've conducted, of course, taking into account all these different covariates, all these different variables that may be impacting their results. So that's definitely more work on our end that needs to be done. But the fortunate part is that we do have information on diet. We do have information on health insurance. Asa can probably talk more on the future direction of the projects, but we are definitely thinking about how all these factors can be influencing the biomarkers of response levels.
Thank you. Any others?
I noticed that for adults, it's primarily the moms that are involved in that. And so we know that for a lot of different reasons, different studies and whatnot. But it was a very striking difference, though. Whereas the recruitment, tell me a little bit about the recruitment of participants and why this could have happened.
For sure. So most of the participants were female. The participants were recruited with our community partners. So with Little Manila Rising and Central California Asthma Collaborative. I think this is the nature of conducting studies with, of course, individuals that we don't have control of who is recruited or who would like to participate in the study. However, I do want to mention that this also brings up a great opportunity for future studies to definitely do more outreach in different places where it mainly more male individuals would like to be part of the study. So yeah, and going back to your question, the recruitment was done through our community partners. There was a list of interests. Individuals would reach out to our community partners to see if they were interested. From there, we would go through the eligibility criteria. But like I mentioned, I think that other studies also indicate that they have more enrollment of females, which that can potentially leave us with the question of, well, what are the biomarker levels in the male population, which, like I mentioned, can be a great opportunity for recruitment efforts to be tailored, having more tailored recruitment efforts for future biomonitoring studies.
Yeah, certainly, I think something we're thinking about the next stages of the project, right? How can you start incorporating more males?
Of course.
I mean, we don't want to give up on one particular group just because it's hard to focus on. But you can still recruit them through the mothers, have them then bring in the spouses, right? So there's, I think this is a very interesting study that opens up a lot of questions in the next stage.
Of course, I agree, and I think that's the beauty of taking a step back and reflecting on what went well with certain studies, what didn't go well, and of course the things that didn't. And also take a second to evaluate what growth opportunities for different research studies. So in this case, now we know that we should definitely spend maybe more time or do a little bit of more recruitment effort to hopefully have a representative sex sample.
Was this your dissertation?
This is one of the chapters. Each chapter focuses on a different data set. So I'll be defending November 22nd. But
right, so hopefully we'll give you some preparatory questions here.
Yes.
Thank you.
Thank you so much for the questions.
Other questions?
I just have a small question. That was a great job, but I was wondering if you had the BMI of the adults.
Great question. Unfortunately, we do not have BMI of the adults. A lot of the literature indicates that we should be looking at the biomarkers in relation to BMI. We are fortunate that we can do this with the children, but with the adults, we just have the age and the gender and other health questions, but we do not have the height or the weight of the adult participants.
Questions from the audience? So welcome, anyone. Well, if there's no other questions or comments, I think we can move on to our next topic. We're just slightly ahead of schedule, but not that much. So thank you again, Kimberly, for your presentation. Thank you, everyone, for the enlightening discussion. So now the next topic we're going to cover is planning for the 2025 SDP meetings. And to lead us to start this discussion, Martha Sandy from OEHHA will be making a presentation. And then we'll have a period of time to ask questions and respond to comments.
Thank you, Tom. And I'm filling in for Stephanie Jermel, who's still out on maternity leave, but will be back for the next meeting. So we're here to talk about the coming year and planning for the meeting. And let's see. So how do I advance? What do I'm pressing the wrong. There we go. Thank you. So we finally today have settled on the dates for next year. It's hard to get you all together. We'll be meeting on March 25th from 1 to 4 and August 27th from 10 to 4 and November 14th from 1 to 4. So those are our expected dates for next year. And now to talk about the topics. Similar to past years, our standing agenda is going to include program updates, as well as more detailed project updates, just like we've done today. And so we'll hear updates on surveillance studies and community studies with those project updates. We'll have ample time allotted during the meetings for discussion and input from the panel and the audience. And then as you look on the right-hand side, we've got a number of different potential topics of interest that we're considering to bring to you for the coming year. And we're looking for input today from the panel on this list and what really strikes your fancy, because we can't do them all. Potential topics include hearing from invited speakers and having a discussion with the panel on biomonitoring health-based guidance values. Hearing from invited speakers on the use of creatinine adjustment versus specific gravity adjustment for urinary biomarker measurements. Discussing how the impacts of climate change could be considered when we're designing our biomonitoring studies. Hearing from invited speakers on studies using silicone wristbands to detect chemical exposures. And we could also hear from experts on microplastics and discuss the challenges and opportunities associated with environmental monitoring and biomonitoring. And continuing with this past year's discussions of oil and gas exposures, we could hear from researchers on the latest findings from ongoing studies in exposed communities. So I'll stop there and see if anybody has questions or suggestions about these plans for the coming year or on any of the specific topics shown on the right side of this slide.
Someone question? I have one with nobody else. So and on that last topic of oil and gas exposures, one thing, I mean, we've been seeing literature come out about exposures in homes to natural gas, components in natural gas. And some of this is fairly new, but there's benzene that comes out of natural gas when you're not using the stove. It diffuses out. You're measuring, not trivial levels in some cases, depending on the benzene levels. So that's kind of an extension of the oil and gas, but I think it's an interesting topic because the use of natural gas for heating and particularly cooking, again, it's linked to climate change, it's linked to climate mitigation solutions. I mean, it crosses over a number of things, but I don't know if there's a way to link some of the biomonitoring to measure exposures to natural gas components in homes. It's been done a lot with measurements of air, but not with a direct biomonitoring study. And it may be difficult to do because the components you're looking at come from other sources. But, okay.
Right, and I think we heard at our last meeting, we had VOCs in the EdGov study, right? And I think there were some elevations associated with having a gas stove or a gas water heater. So we do ask those types of questions in our questionnaire, so we can look at that a little more closely. But it is hard to separate out or pinpoint it to a certain source because people don't just stay in their homes, they're out and about being exposed to other sources of benzene, perhaps. but good point.
Other questions? I have another one. Okay, for climate change, are there markers biomarkers for heat stress that we can use?
You know, that's something we will be looking into. I don't have, maybe other panelists have the answer to that right now, but that is something we could explore. That's why I think you suggested this, Tom, at our July meeting. How can we incorporate these things into our studies, concerns, you know? So we will look into that.
Did you want a sense from the panel about priorities among these, or are these all topics you want to go ahead on? If they've come up and you're asking us if it's okay to keep moving forward on these, or should we prioritize them?
I think it's a mix of what can we do, what's available, who are the speakers, what new research is available, and what are program priorities, and hearing from the panel is what you're most interested in. So we'd like to take all that into account. So I really would like to hear from the panel if any of these topics are really high up on your list of things to dig into.
Carl, okay, Carl, do you have a comment?
Yes, thank you. Martha, this is a question that's probably way too far afield, but as I've listened to some of the presentations today, the biomonitoring program now has a substantial body of evidence that has been assembled from local studies, regional studies, and so forth. Can you make any inferences? I mean, this is a big project, separate project, I'm sure. Can one make any inferences from that about the environmental threats or safety of Californians from these studies that have been done? I know it's a big question, but you might put it out on your far calendar of something to consider sometime.
Yes, it's an important overall question that we should always keep in mind. That's why we're doing these studies, to find out what Californians are exposed to, and are different communities within California exposed to higher levels than other communities, or comparing them to NHANES data and other national data to suggest to us that maybe there's higher exposures to a certain environmental, contaminant that we're more concerned about. So alternatively, it can show that Californians have lower levels of exposure to chemicals.
Well, we might like to think that we do better than elsewhere, but I don't know what's the case. But it might be an interesting separate but big project, probably.
Right. I think it's best to take it sort of chemical at a time, or groups of chemicals. And we've heard presentations on, for example, the Safe PEP study with the school children, where we're seeing lower levels of some VOC metabolites in the urine compared to children in NHANES. So we do try to look at this. Sometimes we can tell, but it's something to keep in mind. Thank you for that.
Thank you.
I see Jenny has her hand up.
I think Oliver was first.
Oh.
You're quicker off the mark, I think.
Oh, I couldn't see his hand. It's so faint.
Yeah, go ahead, Oliver.
Okay, well, thank you. It was all great presentations. For next year, I think the idea of looking at climate change and exposure to climate change and thinking about what to do or how to avoid these exposures, that's really relevant for California. Might be relevant for the nation, for that matter. Especially with the wildfires and the droughts. I mean, we will see more of that all the time. And so we need to think about how to monitor that and potentially at some point even biomarkers of exposures.
Thank you.
Now, Jenny, I think it's your turn.
I wasn't expecting to have to memorize a list, so I hope I got everything on there, but because I didn't write it down before you took off the slide, but I think that I'm just thinking about the biomonitoring, California biomonitoring, and what we should focus on in terms of value added from biomonitoring. I think the creatinine versus specific gravity is just a practical one that keeps coming up over and over again. I think it would be useful because it's very useful to interpret results and isn't as obvious as it might appear for those chemicals that are kind of polar, kind of not polar, or whatever. And then also the health guidance values. What does this mean, or the kind of having guidance for the community about what these things mean, I think would be obviously a valuable contribution. Although I think all those topics are very interesting myself, very much. But also, just to follow up a little bit what you said earlier, that comparing our results to NHANES I've always wondered if we should do some downloading of the NHANES data and then make a subset we should really compare to. For example, California has a much lower smoking rate than the nation and much lower exposure to secondhand smoke because of all of our policies. So looking at values in the blood of people from Tennessee or what have you, they have a lot of exposure from that, which Californians don't have, and it might mask exposure from wildfires or from firefighting or something like that. So I've also been interested to what should we be comparing to nationally? And since we talked about wide-ranging topics, I'm sorry to go off topic a little bit, but I do want to come back to what makes California biomonitoring special versus relying on NHANES and its ability to look for new and emerging chemicals. And potentially to look at populations that are not captured by NHANES, such as more immigrant populations, special worker populations, things like that. So I just want to stay out there. It'd be nice to have speakers to think about how we could move towards maximizing the value of the great program. Thank you.
Thank you. All good things to keep in mind. Thank you very much.
I want to point out this discussion is also open to the audience, both online and in the room.
One of the things that I find particularly interesting, but I think also challenging, is the exposures to microplastics and how, I think most of the studies that have been done have looked at particles specifically and not necessarily measuring the chemical components of the microplastics. And so I was wondering if you had, if the program has done any work kind of thinking about how you would want to go about measuring those exposures to microplastics.
Well, I think that's why we suggested as a topic, we'd invite people to have that discussion.
Yeah. I would be enthusiastic about that.
So in two of the talks today, there was discussion about presenting results to the participants and returning that. Would that be a topic of interest to the biomonitoring program to hear from other experts or in the field who have been doing this for a while? But for one side is, what are the best ways, and maybe bring in some graphic designers. How is it that you can convey a topic that will be very easily understood? Methodological piece on one side. But then the other side, I think, is to their some investigators who are concerned about presenting results about certain chronic exposures or persistent pollutants, for instance, for which the participants may not be able to do anything about it, which may cause stress. So there's a lot of discussion back and forth about this. Some are saying, well, if we have the data, everybody would benefit from at least knowing what they have. On the other side, could it cause stress, given that they can't do anything about it? So discussions like those, it could be something that may be of interest to the biomonitoring program.
Certainly. And, we may hear some updates next year on the project that Rebecca talked about that's just starting on getting, focus groups and feedback from the biosphere participants as to how they liked and understood and what they wished we had told them better or described better for results return. So that you may hear some updates in 2025, and we may in the following year have a session on that. It's a good idea.
Yeah, no, that's wonderful. Do you do much work with the Silent Spring Institute?
Yes.
They have some really cool ways to convey a lot of the data too. So it's worth just looking at different perspectives, different people doing things.
Yes, yeah, the Derby program for online platform, right? Is that the so they have actually presented here maybe 10 years ago, maybe even longer. I can't recall, but they have been at SGP meetings presented. So that's certainly something we would definitely consider.
Thank you. We have a comment from the audience. Lisa Bradman.
I have just a few comments and maybe a couple opinions too. But a few things. One, I'm enthusiastic about microplastics too. I feel like that's something that we need to learn more about. And I don't know if California is unique relative to the rest of the nation, but there's certainly, it seems like every time I open the paper or see a new journal article, there's talk about exposure and health impacts. Just to mention the oil and gas, many of you know we had a conference on air quality and health at UC Merced a couple of weeks ago, and it was really well attended. And 2 or 3 times, community members brought up concerns about the gas fields in the southern San Joaquin Valley. There was also some comments about San Nardo. And I know there's talk about working in the Los Angeles area and the Central Valley, and that seems to be a real community concern. Just my 2 bits there. And then the conference also went well, I think, because we had great translators going on. And just another shout out to Kimberly. We're gonna, her dissertation defense, the first hour will be online, and we're actually, her idea, and we're gonna do it, we're gonna have the same translators to be available online. And I wonder if the biomonitoring programs, for being streamed, that we could consider having streaming these meetings. And that actually might open up a larger population. We have 300 people now on our list for the conference, and it wasn't that expensive. And the logistics, are able to do it online. So it might be less complicated than we think. Of course, there's, to comply with the state standards, but that could be an opportunity to kind of expand community engagement. So just a few thoughts. Thanks.
Thank you.
Was that using AI or was it with?
No, it was using some folks in the Valley.
And I think Rebecca wants to.
Oh, the question. Oh yeah, okay, sorry. The question was if AI was used for the translation, and the response was no.
Sorry. And I thought Rebecca was going to tell us all that, remind everyone that for the SAPEP community meeting, we had it simultaneously translated into Spanish by live people.
Real intelligence, not artificial. Well, Ricky, go ahead.
I mean, actually, one of the things that Asa said was exactly what I was going to say. That I think oil and gas exposures, we were talking about exposures that are, particularly, not unique, but that occur widely in California, and the oil and gas fields near residential areas is like the obvious one. So I would also support that.
It's a topic of broad interest, not just in California, across the country. think we've kind of reached the time limit for this. I don't want to cut people off. Yeah.
All right, just a quick aside on microplastics. A bill many of you may have heard about it, SB 1147, passed earlier this year, and it requires a WEHA to do a risk assessment for the risk associated with microplastics in drinking water and bottled water. So that's something that we just, I think, like a month or two ago. So FYI.
Okay, in the 5-10 minutes remaining, we do make a time period available for open public comments. This doesn't have to be related to any talk, it's just an open mic for the public to come up and make short comments. It's open again to both people in the room and people online. If there's anyone who wants to make a parting comment before we depart for the day. Yeah. And identify yourself for this.
Dr. Hemsa Porterson Chai. I'm the principal investigator for the Hunters Point Biomonitoring Foundation and Program. In March of 2019, I and other representatives of the program met with representatives of OEHHA and Biomonitoring California to discuss the medical necessity for establishing a human biomonitoring program for residents and workers within the 1 mile perimeter of a system of federal Superfund sites in heavily industrialized Southeast San Francisco. In the 5 years that have passed, we have created what I believe might be a model for community exposure science research that centers on human biomonitoring, as well as geospatial mapping for chemicals and radionuclides of concern, documented to be detected in concentrations higher than reference range, and then using information from environmental geographic information systems and enforcement tools like the Cal Enviro screen, the EPA EJ screen, the EPA ECHO enforcement device to further amplify information, and then condensing all of this information and comparing it with questionnaires that are based on the questionnaires used by the CARE project, and then also looking at historical data and environmental testing for industries and regions that are polluted. To make a long story short, the most significant findings, one that I need to bring to your attention, we screened 15 workers who are cited on the federal Superfund site within about 300 feet of a radiation contaminated methane producing landfill. And all of them have chemicals of concern documented to be present in the environment. We are also detecting manganese. Your detection frequency for manganese in the urine is 19%. Ours is about 80%. We have people with manganese levels that are 5 times higher than the level that you define as being for the 95th percentile. But we're also detecting radionuclides of concern. We are detecting radioactive biomarkers. And then in concert with Dr. James Dahlgren, the founder of Pacific Toxicology Laboratories, we have detected products of nuclear fission and decay in 11 current and childhood residents, the majority of whom are living within half a mile of the perimeter of a landfill and the entry to the Naval Radiological Defense Laboratories. So I did want to bring that to your attention. I believe that I shared with you a book in which the findings are published called The Bomb in Our Bodies. We detected potassium-40 in all of the people tested. We detected plutonium-240 44. In most of them, we have a family of 4 with products of nuclear fission, including a 12-year-old boy. We have a woman diagnosed with acute leukemia and given weeks to live, who has both uranium-235 and plutonium-239 detected in extreme concentrations. I do just want to say in closure that of the 15 UC workers who are cited in building 830 and 31 on the federal Superfund site, these are buildings that were never cleared by the California Department of Public Health for human occupancy. This is a violation of the federal Superfund law, and it is a human rights violation that these workers are being exposed and have these chemicals detected in their body. The good news I want to share with you is that HOPO-TX is moving into phase 2 clinical trials. HOPO-TX is an oral decorporating agent that was developed by a team of UC Berkeley scientists, including Rebecca Abergel, who is a professor of nuclear engineering. HOPO-TX in pill form can get rid of some of the most dangerous toxins, including uranium isotopes, gadolinium, lead, cadmium, and these researchers are looking at, I believe, at the Nobel Prize. So we're entering a nuclear age, and we're looking at the prospect of nuclear war. We need to be able to do things to get this stuff out of people's bodies who are facing this level of contamination. I think you should be aware of the astounding work that these UC Berkeley nuclear chemists have done. Thank you.
Thank you. Other public comments? I don't want to cut people off, but we have kind of reached. I just want to end the meeting by making note that the transcript of this meeting will be posted on the Biomonitoring California website when it becomes available. As we saw from Dr. Sandy's slide, the next SVP meeting will take place on March 25th, right? March 25th from 1 to 4 p.m. in Oakland. Is that true? We think so. Okay. In Oakland. And information regarding options for attending the meeting will be available closer to the March meeting date. I want to thank all the panel members and the audience and the online participants for coming today and making it an interesting meeting. And have a good evening. Thank you.